I'm sure you're going to be glad to know we're going to look at some theorems involving the algebraic properties of the cross product. Great, I'm glad you're so enthusiastic. So let's see. U and V are any vectors in space and C is any scalar. Then check this out. U cross V is the negative of V cross U. Now let's see if we can figure out why that would be. Why would U cross V be the negative of V cross U? And the answer is, if you go back to what you studied when you studied determinants, if you switch any two rows, like the second row and the third row in the determinant changes sign. So we've just learned that U cross V, the cross product, is not commutative. Is that our first non-commutative multiplication? The answer is no. Probably you've seen the vector multiplication isn't commutative either. So how about that? U cross V is the negative of V cross U. And of course that forms a right-hand triple as well, but it points in the opposite direction of U cross V. Okay, back to our problem here. Here's another one, vector U cross V plus W. Oh, we're going to see does the cross product distribute over addition, like multiplying distributes over addition in algebra? And the answer is yes, it does. Now, I know we could take the time to prove this by actually just brute force, multiplying it out. Decide there's a vector u1i plus u2j plus u3k, etc. If anyone's real hot to do that, then please do it on your own time. But it's very easy to make a proof like this. Okay, how about this one? What does a scalar do to a cross product? And the answer is, well, it's either the scalar times one vector crossed with the other vector, or the first vector times scalar multiple of the other vector. So it doesn't matter which one you get first. Now, what about cross product of the zero vector and a vector u? Well, recall that means that one of the rows in your determinant would be all zeros. And so when you find the determinant with a row of all zeros, then the determinant is 0. However, you must keep in mind it's not the scalar 0, it's the vector 0, so it's 0i plus 0j plus 0k. So, what about this? U cross u is equal to the 0 vector. Now, why would that be? And the answer is, if you look at the determinant, when you have two rows that are exactly the same with a determinant and elementary row operations, you could subtract one row from the other and you get a row of zeros. Geometrically, you could think of it like this. What is the area of a parallelogram spanned when a vector is crossed with itself? And the answer is, well, what's the area of the parallelogram when you cross a vector with itself? What's 0? There is no vector there. So this is a vector whose length is 0, and the only vector that could possibly be would be the 0 vector, 0i plus 0j plus 0k. And finally, here's another one we could prove by brute force. The dot product of u and v cross w is the same as the cross product of u and v dotted with w. Sometimes that's called the triple scalar product. So here's some more geometric properties of the cross product. I think we'll avoid the cheer on this one. What was I thinking? Okay, u and v are non-zero vectors, and theta is the angle between them. Okay, vector u cross vector v is orthogonal to both u and v. I think I might have already said that. Okay. The length of u cross v, sorry, I'm getting my notation a little bit better here. The length of u cross v is equal to the length of u times the length of v, almost got it, times the sine of the angle between them. Now, why would this be? And the answer is, well, I want you to think back to how you find the area of a parallelogram formed by the vectors u and v when theta is the angle between them, and I think you would say, oh, that's right. It would come about by this being the area of the parallelogram spanned by u cross v. And this is another way to calculate that area when theta is the angle between u and v. There's a nice proof of that in the textbook. You can go ahead and look at it. It's not terribly difficult to understand. Okay. U cross v is 0 if and only if u and v are scalar multiples of each other. Okay, well, what does that mean? Only if one of them's parallel to the other one. Well, why would that be so? Well, because the area of the parallelogram that they span, if they're parallel, is 0. So therefore, the length of the cross product must be 0, and the only vector that has that is a 0 vector, 0i plus 0j plus 0k. Okay? And here's another one. The length of vector v. Did I miss something there? Oh, I did. This is supposed to be, oh, I must have done something with this is supposed to be the length of u cross v, because we've already had this, is equal to the area of the parallelogram spanned by u and v. By the way, of course, they also would span a triangle if you didn't make an entire, just join the tip of u and the tip of v, and they make a triangle, and of course you could probably guess that the area of the triangle was half the area of the parallelogram. So if you wanted to know the area of the triangle spanned by u and v, find the length of the cross product and divide by 2. So, now here's another one. I want you to think about this one geometrically. If u dot v equals 0, then what is the length of u cross v? Take a moment, pause this video, and think about what that is asking you. You'll benefit a lot by being able to reason through this. Okay, unpause. If u dot v is 0, remember u dot v, you could think of it as length of u times length of v times the cosine of the angle between them, right? So if u dot v is 0, then the cosine of the angle between them has got to be 0, as long as u and v aren't the 0 vector. So therefore, u and v are orthogonal to each other. Note that this is dot product, so that's 0 the number, not 0 the vector. So listen, if they're orthogonal to each other, then what is the length of u cross v if they're orthogonal to each other? And that means that they actually form not a parallelogram, actually a type of parallelogram, but a better parallelogram. It's called a rectangle. So what would be the area of the rectangle spanned by u and v? Why, that would be the length of u times the length of v. Thank you very much. I hope you were able to reason that out. You will benefit very much by trying to follow that logic.